Hey guys, welcome to another video. So today we will be solving a sliding window question, fixed sliding window. Yeah, sliding window maximum. It is a hard level question. Okay. Given there's a given array of integer norms, window size k, which is moving from left to right, left to the array to the right. Okay. ठीक है, नॉर्मल चीज़ है, साइज दे दिया गया है विंडो का which is a fixed size. You can only see the k numbers in the window each time sliding window moves right to the return the maximum sliding uh, window, maximum of the sliding window, like the windows maximum, like 3 here. Yeah, here would be also 3, then here would be 5. Okay, yeah, here would be 6, then also 6, then here's 7, sorry. Okay, let's code it. So first of all we are using q. Okay, um yeah, okay, in the queue we will be storing only the record uh thing. Okay, so we need I0 as well as J0 while J less than nums dot size. Okay, what we are doing is that we will need a loop while um while q is not empty and uh, q dot front is less than nums of j. Okay, we are just going to pop that element. Like for example, we are pushing this element 1, then in 3 we are just popping this. If it is empty, yeah, if it is empty, we gonna push that nums of j. Okay, I push this, then if j minus I plus 1 is less than k, that means if j minus I plus 1 is less than k, that means we gonna increase j. Else if j minus I plus 1 is k, that means window size is hit. Yeah, window size is hit. So the answer would be answer dot push back our what q dot front. Okay, yeah, we need answer also, vector int answer. Okay, nice. Now what do you do? What we'll do? You open. Okay, we have stored the answer if it hit the best it hit the uh, window size, then we just push that maximum which is in the front, and then we are going to what, increase I plus plus j plus plus. But before sliding, yeah, we need to see if um nums of I is equal to q dot front, then if it is equal to the front dot pop. Yeah, okay, okay, return answer. 3. Okay, here also 3. Here is, I think, 2. It should be 2. We tried on it. What will happen? Let's try to try on it and understand what is the problem that it creates. 1 3 1 2 0 5. K is 3. Okay, nice. Acha, so first I and j is 0. Okay, we are gonna push it in the queue. So 1 is pushed. Then j plus plus, because window size is not hit. Yeah. Yeah, yeah, yeah. Okay, now since j plus plus, that means again it is not empty. Yeah, and that front is obviously less than the nums of j, that is 3. So q dot pop from the front, obviously. So 3 is in the front. Then j plus plus. Okay, obviously q dot front is greater than, so push 1. Okay, now see, 1 is pushed. Okay, now uh it is the case. Now answer dot push back q dot front, that is 3. 3 is the answer. Okay, 3 is okay, no problem. Then j plus plus I plus plus, but before that, okay, it's seeing that whether I is there. No, no, there is no I q front. There is no in I nums of I in the q dot front. So we're not popping anything, just I plus plus and j plus plus. J plus plus, that means it will check. Okay. So here what is happening is that first of all, it is not empty. Your front is not less than q nums of j. It is not less than nums of j. So it can't pop it. It can't pop that element. Just it is gonna push 2. Okay. Oh. Okay. G. So again the 3 would be there. Then you will remove 3. Then wow. There is a something problem because 1 came but 2 didn't came, which is a error. Nice. this is the case which makes us think how to solve this problem. Like, okay, hmm so see, we need a deck, not a cube. Okay, to solve this question because we need the maximum at the front. So pop back. See, one is not there. So one is pushed. Then j plus plus. Since our j is greater than q dot front, so pop from back elements. Front, let's call it back because the small elements are from back. So back. Okay, not q. I have used Tina. Let us call it q. Doesn't matter. See if it is not empty. One is there. From back, q dot back is less than nums of j. Then we just pop back. Okay, and just push from back only. Push from back only. 3. Got it? Next we again move on to 1. Obviously there is 3 which is greater than 1. Okay, obviously. So we're gonna push it 1 also. Okay, pop from back. Okay, back. Let's see. 7 2 4. Okay, size is 2. Okay, j is in 7. 7, since it is nothing is there, so 7 will be pushed from what, push back na. Okay, then in 2, in case of 2, since it is what, smaller, back is greater, it's greater, so push 2 obviously. Then um is base case heated, answer is 7. Okay, then if sub I equals q dot back, not q dot front, obviously I think. Yeah, because we are pushing from the back, so it would be at the front. So pop where? From where? Pop from front, obviously. Okay, and if we pop 7, then the j plus plus. Okay, obviously j plus plus, since our q is not empty and back is less than our nums of j, that is 4, so pop from back 2 is popped 4. Okay, so I have made it, I think. Yes, let's see. See, dry run helps to understand the code better. Yeah, this is solved. But we can do this more efficiently, more optimized way. Okay, more optimized way. Okay, understood the thing. What you have done? We just checked from the back. Try run it, you will understand it more. Let's again go through it. What we have done? We have make a deck and we initialized basic this thing. Popping when when first of all it it is not empty. Yeah, and from the back you should see that nums of j, if it is there, all the maximum will be here. Okay, in the front. So we just pop from the back only. The back element is smaller. Helps to helps to get what uh decreasing order. Okay. Next, what we done? We we need w inted q obviously. Then we have push from the back. Maximum. What we have got? Then j plus plus. This is basic. This is also basic. This is also basic. This thing that if the front element nums of I, because we are only pushing on the back, all the elements will be on the front. So all the necessary important elements. What? Necessary necessary important necessary yeah necessary important elements are in front. If you pushed the uh, element which is important, if it is in the front, it will be in the front. Okay, so back, so it will be in the front. That's why we checked if it is in the front. If it is not, it will not be found in the latter ons. Okay, and just pop from the front obviously and just increased it. That is the basic thing, because all the lower elements in previous of j, yeah, is not required in the next windows also, but the elements which are in the back of it, like the after elements, okay, is important. How can we ensure that that elements are used by uh, this thing? Is we have got the maximum, so it is at the front. So all the elements will be what? Smaller than that. From the front we have come. All the small elements have just popped. Yeah, from the back, and then we have come. Like empty can be, or any place which are maximum after before that. Okay, so the all the elements which is smaller is popped. Yeah, so we are putting that element which is maximum. That's how you get only the maximum, because that it is not used. That's why. Again, just revise it that, see, um while j less than error of size, nums of size, uh while and is not empty, and back element is less than the what, uh j, yeah. So then if it back element is less than j, then we just pop from back only. Okay, from the back only, because we need the maximum in the front. Then what we have done, we pushed the j element because we have just popped the elements which are smaller, which is not recalled, and then if it not hit, we just j plus plus, again it will check, and all the maximum element will be front. Okay, and then uh, we know that it is gonna help us to get the maximum element from the front. Then if it hit the cases, answer dot front element would be pushed, and then j I, if it is not if it is not found in the front, then it will not found in the, it will be not found in the other also. So if the front q front is nums of I is equal, then front element we have to just pop it. This is the basic. That's all. Okay, if you don't get it, we'll get it. Okay, so I have also done by uh this. Let's see what we have done. We have used take, okay, answer nums, okay, loop from okay, we have first window. Okay, we have calculated for the first window. Okay, um size greater than not empty, and nums of dq back. Okay, this is index. Okay, is less than or equal to nums of I. Okay, it is less than nums of I, then we just pop that element. We're gonna record only the maximum or something. Okay, pushback indexes, answer dot pushback nums of dq. Okay, we stored the indexes. Okay, next window, for next window, from k to I less than n, remove element not part of the current window. Okay, I don't know about this, but this console is better. Okay, thanks. Hope you like this video. Subscribe and comment, like, share.